In 11th class syllabus, there is one important question regarding collision. Okay. So collision is, my students, if a body strikes with another body, or if the path of one particle is influenced due to the presence of another particle. So try to understand it. If two bodies collide with each other, or if the path of one particle is influenced due to the presence of another particle, another body, we call that as a collision. Basically, in our day-to-day life, what we experience if two bodies strike with each other, that is also known as a collision. But if we bombard the alpha rays on the gold foil in Rutherford's experiment, some of the alpha rays deviated their path because of the presence of the nucleus. That is also the collision. Okay. In this collision, my students, when one body exerts a force on another body, so at every instant, the forces being equal and opposite act on these bodies. And in all the types of the collisions, all the basic law regarding conservation of linear momentum and the conservation of energy are obeyed. Total energy, yeah. So, students, remember, this collision is divided into two categories, two types of the collisions. One type of the collision is known as elastic collision, and second type of the collision is known as inelastic type of collision. Okay. In elastic type of collision, what happens? Two bodies collide to each other and the momentum, yeah, I'm talking about the linear momentum, remains conserved. This you have to remember. And second thing is the total energy. Total energy is also conserved. And third thing that you have to remember in case of elastic collision, the kinetic energy is also conserved. And the forces involved in case of elastic type of collision are conservative forces. So initially I was talking in all the types of the collisions, whether we are talking about the elastic collision or inelastic collision, the total momentum, that is the linear momentum, as well as total energy remains conserved. But this special type of the collision, which is known as elastic collision, in this elastic collision, momentum, total energy, and in addition to it, kinetic energy also remains conserved. And remember, the forces involved in elastic type of the collisions are conservative forces. And try to remember one thing, none of the types of the collision in our day-to-day life can be categorized as the elastic type of the collision. However, this type of collision is met with atomic and the subatomic particles, elastic collisions. तो उसके बाद inelastic collision की बात अगर हम लोग कर लें, in inelastic type of the collision, yeah, momentum is conserved. There is conservation of momentum is conserved. And total energy is also conserved. Total energy is conserved. But remember, my students, in inelastic type of the collision, kinetic energy is not conserved. Not conserved. So, a part of the kinetic energy in this type of the collision, in inelastic type of the collision, is converted into another form of the energies. It can be heat, it can be sound energy, any other type of the energy, but kinetic energy is not conserved at all. So, let's talk about elastic collision in one dimension. In order to derive the equations, let me take here two bodies. Let me call one body as body A and the second body as body B. And let's call their velocities, initial velocities. before collision, yes, exactly, are U1 and U2. So this is the condition of the two bodies before collision. Yeah. So after some time, what happens? If U1 is greater than U2, then and only then, after some time, the two bodies will collide with each other. Yeah, this is body A, this is body B. Let's call here mass is M1, mass is M2. Yeah, this is the condition during collision. During collision. This time we are talking about collision in one dimension. So what will happen to them? The two bodies will move with some velocities after collision. Let's call their velocities after collision be V1 and V2, and the masses will remain same as M1 and M2. So this is the condition of the two bodies after collision. Yeah, try to understand. We are talking about elastic collision in one dimension. In elastic collision, we talked the momentum, linear momentum remains conserved. That is, linear momentum before collision is equal to the linear momentum after collision. Total energy is conserved and the kinetic energy is also conserved in case of, elastic collision. So, in order to derive the expression for the velocities of the two bodies after collision, what we will take some of the equations. We were talking in elastic type of the collision, the total momentum is conserved. What is momentum of this body? Yeah, it is M1 U1, momentum of this body plus M2 U2. So this is the total momentum before collision. And total momentum after collision will be M1 V1 plus M2 V2. Exactly. So do one thing, transfer these equations. M1 U1 minus M1 V1 is equal to M2 V2 minus M2 U2. Take out M1 common. So M1 into U1 minus V1 is equal to M2 into V2 minus U2. Call this equation number first. This equation we have obtained on the basis of conservation of linear momentum. And second thing is that kinetic energy is also conserved if we are talking, this is the elastic type of collision. So what is kinetic energy before collision? Okay, kinetic energy before collision will be, kinetic energy of this body, that is 1 by 2 M1 U1 square plus 1 by 2 M2 U2 square is equal to, 1 by 2 M1 V1 square plus 1 by 2 M2 V2 square. This is the total kinetic energy after collision of the two bodies, and this is the kinetic energy before collision. According to conservation of kinetic energy in elastic type of the collision, so perfectly elastic type of the collision, we can call here the total kinetic energy before collision is equal to total kinetic energy after collision. Okay. After transferring the equation, what finally we will get? We will get 1 by 2 M1, this is U1 square minus V1 square is equal to 1 by 2 M2 V2 square minus U2 square. 1 by 2 and 1 by 2 will go. So finally we will get 1 M1 into U1 square minus V1 square is equal to M2 V2 square minus U2 square. Call this equation number second. So what we will do, my students, we will divide this second equation by first equation. On dividing second by first, what we will get? M1 will go and U1 minus V1 will go with U1 minus V1. There we will get U1, this is the equation that we have to use. We will get, on dividing second by first, we will get U1 plus V1 is equal to V2 plus U2, or which implies U1 minus U2 is equal to V2 minus V1. Okay. Try to catch this equation from this. So this is U1 minus U2. U1 and U2 are the velocities, initial velocities of the two bodies. So we can call here, this is relative velocity before collision. Okay. So relative velocity before collision is equal to V2 minus V1 is relative velocity after collision. So remember, in case of elastic collision in one dimension, the relative velocity before collision is equal to relative velocity after collision. What about the ratio? So simply we can write here V2 minus V1 divided by U1 minus U2 will be equal to 1. And remember students, this ratio, that is the ratio of relative velocity after collision to the relative velocity before collision, is known as coefficient of restitution or coefficient of resilience. Remember, denoted by E. So E is coefficient of restitution or coefficient of resilience. In case of perfectly elastic type of collision, it is equal to 1. What is basically E? E is the ratio of relative velocity after collision to the relative velocity before collision. Yeah. And remember, for perfectly elastic type of collision, its value is equal to 1. For perfectly inelastic type of collision, its value is equal to 0. And for other types of the collisions, which lies between perfectly elastic to perfectly inelastic type of collision, its value lies between 0 to 1. So we can write here the value of E lies between 0 to 1. You have to remember it from the entrance point of view. Coefficient of resilience or coefficient of restitution. Ratio of relative velocity after collision to the relative velocity before collision. And remember, we are talking about the collision, perfectly elastic collision in one dimension, and in that collision, the relative velocity before collision is equal to relative velocity after collision. This is the equation. With the help of this equation, we can calculate what are the velocities of the two bodies after collisions. So how?